In this video, we're going to look at some application problems with our 3x3 systems of linear equations. So just like when we did applications of our 2x2 systems, we need to read the described situation, define our variables. In this case, we'll have three, an x, a y, and a z, and then form a 3x3 system. So since it's a 3x3 system, we have three variables and we should also have three equations. Then we go about solving it in the same way that we've done in the past. Okay, so let's go ahead and look at this example one. All right, so it says a candle company sells three candles for $15, $10, and $5 per unit. Okay, so that's important there. We have three types of candles sold for three different dollar amounts. In 1 year, the total revenue for the three products was $550,000. So our total revenue was $550,000, which corresponds to the sale of 50,000 units, so 50,000 candles. The company sold half as many units of the $15 candle as units of the $10 candle. And then we want to know how many units of each type of candle were sold. Okay, so the first thing we have to do is define our variables. Now remember, when we're defining our variables, we essentially just want to think about what question are they asking us, and that's what we're going to let our x, y, and z equal. So on this one, since it's how many units of each type of candle, and we have these three different types of candles, the ones that sell for $15, $10, and $5, that's going to be our x, y, and z. So I'm going to let x equal the number of $15 candles sold. I'm going to let y equal the number of $10 candles sold. And then z will be the number of $5 candles sold. Okay, and remember to be specific when you're defining your variables. So don't just say x equals $15 candle, because what does that mean? Okay, how can x equal a $15 candle? It's important that you say that it's the number of those particular types of candles. Okay. All right, so we know what our variables are. Now we need to define our system. Okay, so if we look back at the information that we're given here, the first thing they tells us is that in 1 year, the total revenue of the three products was $550,000. So that's going to help us build one of our equations dealing with the prices of these different candles. So we know that every X candle is sold for $15, every Y candle is sold for $10, and every Z candle is sold for $5. This adds up to a total of $550,000. So that together is our first equation. So 15x plus 10y plus 5z equals $550,000. Okay, now the next thing they tell us is that they sold 50,000 units. So if we put together the number of candles sold of these X, Y, and Z types, they add up to 50,000. So that just means X plus Y plus Z equals 50,000. All right, the last piece of information they told us is that the company sold half as many units of the $15 candle as units of the $10 candle. So half as many units of the $15 candle as units of the $10 candle. Okay. Okay, so half as many X's as Y's, which means if we know what our Y is, we need to cut it in half, and that would give us our X. So half of Y is equal to X. half as many units of the $15 candle as units of the $10 candle. All right, guys, so we now have our system. We have our three equations, so we have our system. Okay, so now we need to solve it like usual. Now we did an example similar to this in the previous set of videos on the 3x3 systems, where we have our three equations, but one of the equations only has two variables, okay? And you might recall that when this happens, essentially what that means is this third equation, it's already set for now. We don't have to do anything with it. But since it's missing the z variable, we put the 1 and 2 equations together, eliminate z, and then that will go with this third equation to form our 2x2 system. So we only need to create that one pair and eliminate our variable that's missing from the third equation. Okay, so that is our 1 and 2 equations put together. Okay, now like I said, since the third equation does not have a variable z, that's our only choice for what variable we're going to eliminate here. So we'll need to multiply the bottom equation through by a -5. So just copy down that first equation. And then our bottom equation would be -5x minus 5y minus 5z is equal to -250,000. All right, now add our equations together. The z's cancel, and we're going to have 10x plus 5y is equal to 300,000. All right, so that is going to be my equation A. Okay, so then putting together equation A with equation 3, I don't know what happened over here, these don't line up. Okay, putting together my equation A with my equation 3, we have our 2x2 system. That's 3 and A. Okay, now typically when I'm solving a 3x3 system, I'd like to continue with elimination just because that's what we've been doing. It's just easy to stay in that groove. In this particular situation though, I'm actually going to go with the substitution simply because this top equation is already solved for x. So we might as well just substitute that into the bottom equation, solve it out for y, and then back substitute from here. So I'm actually going to substitute on this one. So my equation 3 is going to go into my equation A. So we would have 10 times 0.5y plus 5y equals 300,000. So 10 times 0.5 would be 5. 5 plus 5 is 10y. This is 10y equals 300,000. And then just dividing by 10 on both sides, we get y is equal to 30,000 candles sold at y was our $10 candle. Okay, so 30,000 of the $10 candles were sold. I'm running out of space here. Let me give myself another page. Okay, all right, so now that we have our first variable, we just need to back substitute it in order to find our next one. So looking back at either our equation 3 or A that made up our 2 by 2 system, 3 looks nice and easy to work with. So I'm just going to plug that 30,000 in for my y in equation 3. And that would just give us x is 15,000 candles sold at our x, if you recall, was the number of $15 candles sold. So that is our second variable. All right, and then lastly, we need our z. So going back to one of our original equations, now this time we can't go back to equation 3 because it doesn't even have a z in it. So we have to use either our equation 1 or 2, plug in what we know for the x and the y, and solve for z. Okay, so I think probably equation 2 looks a little bit easier to work with. So our equation 2 was just x plus y plus z equals 50,000. Let me just write that down here. Okay, and then plugging in what we know, we'll have 15,000 plus 30,000 plus z is equal to 50,000, or 45,000 plus z is equal to 50,000, which means z is equal to 5,000 candles sold at $5. All right, guys, so those are our 3 variables. So we sold 30,000 of the $10 candles, 15,000 of the $15 candles, and 5,000 of the $5 candles. So if you want to put it together as an ordered triplet, we have 15,000 as our x, 30,000 as our y, and 5,000 as our z. All right, guys, so there's a second example worked out in the notes on Blackboard. If you have any questions on either one of them, as always, send me an email and I am happy to help.